What is F?
Oh my gosh.
What?
I don't know, Wait, did you start recording like just?
Yeah, I did.
Oh my gosh, like the whole Zoom just crashed for a moment.
Huh?
Wait, never mind. F is...
Hello? What is F? Are you there?
Hello?
Are you there?
Hello?
Yep.
Hi, what?
What is F? FIST. These are characteristics of binomial distribution. What is F?
Huh? For binomial?
Huh? Hello?
Hello?
Are you with me?
Yeah?
So what is F? I mentioned this before. Fixed number of trials. Okay?
Okay.
What is I?
Oh, I don't
Independent.
remember.
It should be on either on the first or second page of your binomial lecture notes. 100% is there. The characteristics of a binomial distribution.
No, though. Okay, wait, hold on. It's only the word, but it's not the
FIST.
meaning of it. Yeah, it's just FIST.
Sorry again?
It's just FIST.
You mean they give you FIST also?
Huh? No, you wrote FIST.
Yeah lah. I mean, I
But
expect
got...
you to know lah. Okay, never mind. You write now. F is the fixed number of trials. I is independent, means the events are all independent. The selection is independent. Okay?
Okay.
S means same probability. Okay? T means two outcomes. So once you see that it hits all four characteristics, right? This question is a binomial question. But it should be very, very obvious one. Once I see the fixed number of trials, I see as a random sample of 9 taken. Oh, straight away I know already. Because in DRV, it will not tell you this. It will not tell you a random sample of 9 is taken.
Okay.
Yeah. Can?
Yeah.
Okay. So since you're done with binomial, I want to move on to normal distribution. Have your school went through normal distribution?
Yeah, halfway.
Halfway. Okay. Halfway, can you just take a snapshot of the tutorial and send me?
Okay. Like the questions that my teacher will go through in class, or like the revision ones?
Sorry again?
Like the questions that my teacher will go through in class, or the review problems?
Your teacher is going to go through anyways, so let's not deal with that lah.
Sorry, what?
I mean, if your teacher is going to go through that, then let's not do that, because if not, you'll be going through it twice.
Yeah, kind of. So, like, for to tell whether it's DRV or binomial, then I just use the FIST.
FIST.
Like,
yes.
to tell. Then what about like the rest?
What about what?
Like normal and everything.
You will know one. It will tell you it's normally distributed.
Oh, okay.
Yeah.
So it's just DRV and binomial.
It is really not difficult to tell. You look, you will know one. The
But then
only
there's this
reason.
question my teacher sent.
Sorry again.
But there was this question my teacher sent, and I didn't know it was binomial because it looked like DRV.
Okay, but DRV can be together with binomial.
Huh?
Okay, look. You need to understand this thing. This big circle is DRV. This small circle here is binomial. So but in binomial distribution, right, you are actually using discrete random variable concept. Because binomial distribution measures discrete random variables. Correct?
Yeah.
Yeah. The expectation of x in binomial is n times p. Yes, correct, right? But it is also equals to the summation of x times its corresponding probability in the PDF.
Okay.
So how to identify whether is it binomial or discrete random variable? You have to identify all of it as discrete random variable. It's just whether can you use the binomial equations, whether you can use the binomial formulas to find the expectation. All binomial questions come from is actually a discrete random variable question. But you have to see whether did they give you fixed number of trials? Did they give you probability of success? If yes, then you can say that x follows a binomial distribution n comma p. If they did not give you any of these nonsense, they expect you to find for every single value like x equals to 1, what is the probability, x equals to 2, what's the probability. Chances are you need to plot the PDF. You understand?
Yeah.
Yeah. But once you do like enough questions for binomial and DRV, right, you will start to know when is it a binomial, when to use the binomial technique and when to use the DRV technique.
Okay.
Yeah. It's like squash and you play badminton before?
Yeah.
You play tennis also, right?
Yeah.
You won't use badminton technique to play tennis, right?
Yeah.
Yeah. Why? Because if you keep playing tennis, you will know that, oh, this is how I play tennis. But for someone who has always been playing badminton, suddenly switch to play tennis, I won't be able to understand how to play tennis. I will be using badminton technique to play tennis.
Yeah.
Yeah.
Mm.
Okay, thanks for sending me. We will be going through. Okay, normal distribution is the best, I tell you. You will love normal distribution.
Huh? It's so hard to understand.
Oh, once you understand statistics, right, you realize that, wow, pure math is bullshit. Okay, where did your teacher stop with you?
Oh, actually, he almost finished everything. He's just left with one example, and then he's done.
Oh, for normal distribution.
Yeah.
Then very good. Okay, I don't need you to do anything. Okay, today I will just primarily be needing you to help me do some calculation.
Okay.
Okay, I will be doing most of the presentation myself. Okay, I just need you to see how to break down the question for normal distribution. Okay, ma?
Yeah.
Yeah. Okay, let's take a look here. This thing is very irritating. How do I have the whole whiteboard? How do I have the whole whiteboard? If pen, object snapping, format background. Is it format background? No leh.
I don't think so.
How do I, because I got this thing, like what, my whiteboard. I don't want this thing. I don't want all these buttons here.
It's always there.
Yeah, I know. But how do I remove it?
Toolbar location, I don't know.
Active pen. Oh, I can take away the bottom part already. Object snapping. Is it?
No.
Oh, object snapping is quite good actually. Okay, never mind. Okay, let's start with this. So get your GC ready. I just need you to help me to calculate. Can? Are you ready? Okay, so let's break down this question. The timing, not times lah, walao. The timings taken by two runners A and B to run a 400-meter race are independent. Okay, look, so they will always be independent. If it's dependent, right, it will be difficult to calculate the probability really. Okay. And sorry, hold on. Okay, I'm back. Hello?
Yeah.
Yeah. Okay, carrying on. It's independent and normally distributed. See, they will tell you. They will tell you it's normally distributed. So this is when you know that it's normal distribution. If you still go and you do DRV or binomial distribution, right? You know what you should do during A-levels? You should stand up, turn your paper around, stand up, then push the chair in.
Gosh.
Yeah, then you can just slowly, just take your pencil case and your GC, right? Slowly walk to the exit. Then just turn back a bit, and then your friends will look at you, then give them a very light wave.
A light wave?
Yeah, very light wave, just, yeah. Then just very, very confidently, just take that one step out.
Okay.
Yeah. But no, you're not going to do that. You're not going to do that.
I will listen to you.
Yeah. If anything, right, you should fail in the most glorious manner. You should do to the end and then just fail. Like give 200% effort and fail.
Are you kidding me?
Okay, carrying on.
By putting 200%, I won't fail already.
What again?
By putting in 200%, I won't fail already.
Hard to say. Hard to say. If you run very hard and very fast, okay, in the wrong direction, you will end up at the wrong destination still. Makes sense?
Yeah.
Yeah, okay, carrying on. Okay, so we have A and B. They run a 400-meter race. Their timings are independent, means even you are overtaking me, I don't care. I will still run as per normal. Okay, I won't feel anxious. I will still feel like the same. Okay, the mean is 45 seconds for A, 44.2 seconds for B. Standard deviation is 0.5 seconds for A, 0.8 seconds for B. Okay, so this is when I'm going to write the definition down first. Okay, so I will know that I will let A be equals to the timing of A and B be equals to the timing of B, of course. So A will follow normal distribution. After I will define the distribution, right? It will be equals to 45.2. Sorry, 45.0. Actually, don't need write 45.0, just 45. And standard deviation will be 0.5 squared. Okay, For B, it will follow normal distribution, 45.2 and 0.8 square. Can? So carry on to break down this question. It will be that the two runners are to complete a 400-meter race for which there's a track record of 44.5 seconds. Okay, so their mean is 45 and 45.2 lah. So there is an Olympic record somewhere lah. That is 400 meter is 44.5 seconds, which is pretty fast lah. Okay, calculate the probability that a runner A breaking the record. So which, in other words, which also means we want to find the probability of A breaking the record, means we want it to be lesser, okay, than 44.5. Okay, can you find it for me?
Wait, the X is CDF, right?
CDF, you always use CDF, you never use PDF.
Yeah, I use CDF. Then there's the lower and upper limits. The lower is 40.
No,
5?
lower is negative E99.
Always?
No, you look at this, A lesser than 44.5. Lesser than 44.5. So it goes all the way to negative infinity.
Okay.
Upper bound will be 44.5. Right?
Yeah.
Yeah, come on, man. Can go a bit faster.
Wait, but the answer's wrong. I got 0.02275, but the answer is 0.15.
What do you key for your standard deviation? Is it 0.5 or 0.5 square?
0.5. I'll try again. Oh, okay, I got it now.
What went wrong?
I don't know. I just did the same thing.
Something must have went wrong. Okay, never mind. Come. What's the answer?
It's 0.159.
159. Exact?
Yeah. No.
Tell me.
8655.
865. Okay. So it's 0.1593 SF. Okay, part 2. No, sorry, not part 2. It's a hence question. Hence, show that the probability of runner B breaking the record is greater than that of runner A. Hence, show that the probability of runner B breaking the record is greater than runner A. Hence, show that the probability of runner B breaking the record is greater. I think we just have to find probability of B, right?
Yeah. And then show that number is like bigger.
Yeah, I think it's just like that, right? What kind of question is this?
Why? What's wrong with it?
It's so weird. And
Oh,
anyway,
no, but then must use hands, what?
yeah, then we are using this part already, right? Hence means using the previous part, right?
Yeah.
Yeah, we're using the previous probability.
Okay.
So can you find for me for probability of B? Smaller
1
than
minus, is it?
44.5. Sorry again?
1 minus, is it?
Yeah, just calculate for me. Normal CDF.
Huh? Normal CDF?
Yeah.
Okay.
Why you use 1 minus?
You said must use hands.
Then why will you want to use 1 minus?
I don't know, I was just guessing.
Yeah, cannot. Math cannot be. You cannot guess in math. You should guess at like some like the price is right or like Wheel of Fortune. Something like that. Yeah.
0.5987.
5987, exact.
59871.
Okay. So from here, okay, you can show that this is greater than probability of A lesser than 44.5. That's about it.
That's using hands, man.
Yeah. Cause you.
How?
Okay. Hence means what? Hence means that you got to use the previous given result. What was the previous result? The previous given result was just this.
Yeah.
Yeah. So to show that the probability of runner B beating the record is greater, we just have to find what's the probability of B breaking the record and show that the probability is greater.
Okay.
Make sense?
Yeah.
Okay, part 2. Find the probability of runner A beating runner B. Okay, runner A beating runner B means what? Who will have a lower timing? Who will have a lower timing?
A.
A, correct. So it's the probability of A lesser than B. Agree?
Yeah.
Yeah. So from here, how do I find probability of A lesser than B? I cannot. So I have to rearrange the variable to give me probability A minus B lesser than 0. So from here, I'll be able to find a new, I have to define a new random variable, which is A minus B. Okay, so to define this new random variable, I have to find the expectation of A minus B, which is equals to expectation of A minus expectation of B. And expectation of A is 45 and expectation of B is 45.2, right? Which is equals to minus 0.2. Okay, so variance of A minus B will be equals to variance of A minus variance of B, which is equals to 0.5 square, plus. Take note, I made a mistake here, plus, because when you take out the negative sign from minus B, when you take out the minus 1 is minus 1 square. So the minus 1 square will give you positive 1. So you have variance of A plus variance of B. So over here you get equals to 0.5 square plus 0.8 square. Okay, come, do some math for me. Hello.
Wait, that means for the expectation it's also always minus, then variance is always plus, is it? Like if you
Again,
separate them.
if
Or
it's a
for
minus, right?
expectation.
If there's a minus there, yes. Because you have to look at it like that. Variance of A minus B is equals to variance of A plus variance of minus b. Then when you take out the negative, so that because there's a coefficient of -1 here, can you see?
Yeah.
Yeah. So because there's a coefficient of -1 here, so when you take it out, you get plus -1 square. This is what is happening.
Why must square?
Can?
Why must we square?
Huh? It's the properties of expectation of variance.
Okay, so if it's positive, then nothing happens, right? It's just positive. Like
Yeah,
plus.
correct. You
What
remember
about
or not?
expectation?
You remember this or not? Let's say this is 5. It becomes variance of 2x plus variance of 5. Remember? Then when you take out, so you factorize out 2, you get 2 square variance x plus variance of 5 is 0.
Oh, okay, yeah.
Remember now?
Yeah.
Nice. Can I proceed?
Okay.
Can you tell me the answer?
Zero 0.89.
0.89. Okay, so from here, we are going to define a new random variable, which is a minus b. A minus b follows normal distribution minus 0.2, comma, square root of 0.89 square. Okay, why did I do this? You want to make a guess? Why don't I write 0.89 instead?
Because you need to like only put the square root of it.
Correct. Because when you input into the calculator, you're inputting the square root of it. So for me, right, I want to play things. I want to play it very, very safe. I don't want myself to key in 0.89 in a moment of panic. So I will always put in the square rooted form. Can?
Okay.
Okay. Then for part, sorry. So from here, I will be able to find probability of a minus b to be lesser than 0. Can you find it for me?
Okay.
So your upper bound will be 0, your lower bound will be minus E99.
Wait, say again.
No, never mind, it doesn't matter.
Oh. Uh, 0.58394.
0.3894.
58.
Oh,
No, 0.58394.
58394. Okay, so which is equals to 0.5843 SF. Okay, part 3. Find the probability that the total sum of 4 randomly chosen times of A. 4 randomly chosen times of A means what? Is it 4A?
No.
No. Then what is this? What is it? How do I express 4 randomly chosen times of A? It will be A1 plus A2 plus A3 plus A4 because they are independent observations. Okay?
Okay.
Yes. So it's more than 4 times a randomly chosen time of B. So what is that? Is it 4b, or is it b1 plus b2 plus b3 plus b4? Which one is it? Hello.
A
What? Where got A? I never give you option A or B.
No, as in A1 plus A2 plus A3 plus A4.
No, I'm on the second part already. I'm asking 4 times a randomly chosen time of B. Which one is it?
Huh?
Dude, I'm here.
Yeah,
Yeah, then when you tell me A1 plus A2 plus A3 plus A4.
because it has to be more than that of B, what?
No, I'm asking you more than 4 times a randomly chosen time of B. How do I express 4 times a randomly chosen time of B? You understand what I'm trying to
Times
say?
4 times 4.
So which expression?
B1 plus B2 plus B3 plus B4.
Wrong. Is this one.
Why?
Is 4 times a randomly chosen time of B. Means I'm going to take one randomly chosen time of B. I'm going to multiply it by 4 times of it. But for the expression at the beginning, for A1, they say the 4 randomly chosen times. Means these times, right, are different. There are 4 different timings.
Oh, okay. Then don't need to choose. Just take B.
Never mind. I do the question, then you observe. Okay, so how I will do this question is this. So this is in English, okay? The intention of the setter, right, is that, okay, you know what? There are some students who do not know how to translate, okay? I want to test their ability to translate, okay? So I'm going to take away some marks from students here. So let's see if they can translate properly. So if you can translate properly, you will get the marks. I want to find the probability of the total sum of 4 randomly chosen times of A is more than 4 times a randomly chosen time of B, which is A1 plus A2 plus A3 plus A4. And the total sum is more than that, so it's greater than 4B. This is the probability I want to find. So which means I'll bring the 4B over to the other side. I have A1 plus A2 plus A3 plus A4 minus 4B. Okay, which is greater than 0. Okay, so now I have a new random variable, which is this. I need to find the expectation and I need to find expectation and variance of this random variable. So to do that, firstly, I'll need more space. Oh man. Okay. So over here, I need to find the expectation. Oh God. I need to find the expectation of A1 plus A2 plus A3 plus A4 minus 4B, which is equivalent to expectation of A1 plus expectation of A2 plus expectation of A3 plus expectation of A4 minus 4 expectation of B. Okay? Can you calculate that for me? So in other words, this is actually 4 times expectation of A minus 4 times expectation of B.
It's a negative value.
Doesn't matter.
Negative 0.8.
Negative 0.8. Okay, so now we move on to the variance. We also need to find the variance. So the variance of the new random variable will be variance of A1 plus variance A2, A3, A4, so on and so forth, until the this last part over here, take note. Because we are finding the variance of minus 4b. Okay, we are finding the variance of minus 4b. So for this minus 4b, we have to factorize it out. We will get 16 plus minus 4 square, right? That's why we get 16 variance b. Okay?
Yeah.
Yeah, that's why, and hence we get what is at the bottom. Can you help me to calculate this? So this is equivalent to 4 times variance of A plus 16 variance of B.
You must square root. Must I take the square root for variance?
What do you mean?
Like instead of 0.5 squared, it's just 0.5.
Huh?
Variance
do you
what?
mean? What is variance? What's the variance of A?
0.5.
What is 0.5?
The standard deviation.
Exactly. Then what is variance? What is variance? Hello? By now
By
you should know.
expectations, is it?
By now you should know already. I've been going through since day 1 in discrete random variable. Do you know that?
So it's 0.5 squared.
Yeah. Variance is standard deviation square. Okay?
11.24.
What's the answer?
11.24.
11.24. Okay. So over here, we will have minus, so the new distribution will be minus 0.8, comma, square root 11.24 square. All right. Actually, a better way will be to let this whole thing, right, be something like, for instance, like let W be equals to A1 plus A2 plus A3 plus A4 minus B. If not, you see, I keep repeating this, that. Wow, it's damn insane. And then here I need to rewrite again. So in exam, right, to save some time, you want to maybe redefine your new random variable as a single letter. Okay? Then from here, you make things a lot easier and faster. So you need to find probability of W to be greater than 0. Right? Because keep in mind in the question. Okay? So from here, you'll be able to find your answer. So can you find the answer for me using normal CDF?
0.405. 0.4057.
Okay. 0.4057. So you get 0.4063 SF. That should be the answer. Can understand? Question 1? Any part that you don't understand?
No.
Okay, great. Let's move on. Let's move on to the next question. Okay, let's break down this question first again. Durians are sold at $7 per kg, okay? And the mass of a durian is normally distributed. So upfront, you already know, okay, this is a normal distribution. Okay, the mean is 1.5 kg, the standard deviation is 0.2. Then also there is another mango was sold in bags of 5. There's a reason why they tell us this. 2 kg per kilogram. Okay, a mass of a randomly chosen mango is normally distributed with mean 0.4 kg and blah blah blah. Okay, all these are the standard normal distribution parameters that they should give us. The masses of the durians and mangoes may be assumed to be independent of each other. Basically means that, oh, how the durian weighs and how the mango weigh, right, is like they do not depend on each other lah. Can find the probability that a randomly chosen bag of mangoes, randomly chosen bag of mangoes has selling price exceeding $4.20. Okay, so as we can see here, firstly we always define first. Okay, we always define first. So we let D be equals to mass of durian. And M be equals to a mass of a bag of mangoes. Okay, so now we want to find the probability that the mangoes have a selling price exceeding $4.20. Okay, the mango, one bag of mango is priced at $2. Okay, so now I want it to cost, sorry, 1 kg, not one bag, 1 kg. What am I writing? 1 kg of mangoes it costs $2. Okay, now I want to find $4.20. $4.20 will be what? How many mangoes? How many kg of mangoes?
Wait.
Hello.
It's so embarrassing to type on the calculator. 2.1.
Hello. Yeah, 2.1 kg. So you know 2.1 kg, a mass of 2.1 kg will give you $4.20. The reason why I want to do this conversion is because our understand what is a random variable. Your random variable is in terms of mass, but they're asking you for selling price exceeding 420. Okay, so this is why I want to convert the kg to, I want to convert the dollar to mass first, so it's easier for us. So we want it to have selling price exceeding. So we want the probability of the mangoes to exceed 2.1 kg. Don't have to write the units actually. Okay, but before we even do this, right, we need to write down the distribution first, of course. So we have durian follows normal distribution. What's that? 1.5 and standard deviation 0.2 square. Net. Is
Yeah.
variance 0.2 square or 0.2?
0.2 square.
Very good. Then we have mangoes, follows normal distribution, 0.4 and 0.05, right? Square.
Yes.
So from here, we can find the probability of M to be greater than 2.1 kg. And can you find the answer for me? That's for part 1.
Zero.
0.
Wait. Yeah, legit. The lower is 2.1, then upper is e to the power 99, right? Hello?
E99, yeah.
Then the
Upper is E99, then lower is 2.1.
yeah. Then after that is 0.4 and 0.05, right?
0.4 and 0.05. Yes, correct.
Is 0.
Is 0. Sorry, give me a while. Yo, man.
Yeah.
Yep. So find the probability that of the event that both are randomly chosen during our selling price exceeding for 20 cents. You get 0.
It's legit 0. Use CDF, right?
Hardly will the answer be 0 one. Cannot be 0. CDF, correct. Or unless we tabulated the money wrongly. 2 kg per kilogram. We want it to be more than $4.2. So it must be more than 2.1 kg. If you check the answer, is the answer 0? No, right? Cannot be.
It's not.
What is wrong?
It's okay. The answer is 0.819.
Oh, my bad. My bad.
Why?
I know why already.
Oh, is it durian? No,
No.
what? It's correct, what? It is. Why? I'm like reading the question again. I was like, nothing wrong, what?
There is something wrong. I made a mistake. I made a very grave mistake. It said the mass of a randomly chosen mango. I fell into their trap. Then here is a randomly chosen bag of mangoes.
So
This distribution is not for bag of mangoes. This distribution is for a mango only, like one mango, one.
wow.
You understand?
No, it's the same words, right?
Same, yeah, no, look here. The
Oh,
mass,
my bad.
don't
But how
embarrassing
to do? How to do? No, my English isn't that bad, okay? It's just because it's
Okay.
math, that's why.
The mass of a randomly chosen mango. This is the distribution. Mass of, sorry, it was my fault. It was my fault to begin with because I defined it that way. It was my fault. It's none of Net CJC's fault.
Oh my God, don't say that.
Mass of a mango. It was my fault. Okay. So now we need to find a randomly chosen bag of mangoes. So a randomly chosen bag of mangoes will have, there will be how many mangoes inside? There will be 5, right? Make sense?
Yeah.
Yeah, because they're sold in bags of 5. So we will need to find M1 plus M2 plus M3 plus M4 plus M5. Correct?
Okay.
Yeah. So in other words, I want to let W be equals to this. So I want to find the expectation of W. So expectation of W will be 5 times of the expectation of M, which is equals to 2. Then I'll find the variance of the W, which is equals to 5 variance M.
Wait, there's 5 because
In one bag, there are 5. Now look at the question part. Look at part 1. I want to find a randomly chosen bag of mangoes.
oh, okay. Oh, am I supposed to count the variance for you?
Of course.
Zero point zero one two five.
0.0125. You times 5 already, right?
Yeah.
Okay. So after you're done with this, then we can have the new distribution, which is W follows normal distribution, 2 comma square root 0.0125 square. Then you want to
0.18555.
0.18555, which is equals to 0.186. Correct?
Yeah.
Yes, it was my mistake because you see, this is to let you guys know out there, right, how important definition is. Once you define the definition wrongly, right, that's it. You can turn your paper on to the underside, then carefully like rise to your feet, okay, push the chair in, okay, in a very delicate manner, okay, and then in a very slow and gentle manner, right, walk all the way up to the door. Then just as you are about to exit the hall, right, just turn back slightly, and then you grin and give a very light wave. Then
Wait,
you,
actually. Oh, no, sorry.
were you listening to what I was saying? You know?
Yeah, you're talking about pushing the chair and stuff.
Yes, correct.
Wait, but then is 5 variance and no need times anything, right? Like square outside anything.
Don't have to. Why?
Because it's just 1, is it?
No. Because variance of W is equals to variance of M1 plus variance of M2 plus variance so on and so forth until variance of M5. I have 5 variances of M here, that's why. That's why it's 5 times variance of 5. If it were to be variance of 5M, yes, then I will need to have 25 variants of M. This is the misconception. You have to understand whether are you finding 5 independent values or 5 times that one independent value. There's a difference. 记不记得?
Okay.
I hope I clear this misconception because I think if anybody were to screw up normal distribution question, this will be the part where they find the variance wrongly.
Yeah.
Can?
Yeah.
Fantastic. So if you were to be confused with this variance part, right? You know, during exam, you know what you should do?
Yeah, pushing my chair and leave.
No. You should turn the paper around first. In case people, right, copy the wrong answer. You get what I mean?
Okay.
Yeah, turn the paper around first. Then after that, slowly rise to your feet. Yeah. Then you know what happens after that? Hello?
What happens after that?
Yeah. After you rise to your feet.
Push in the chair.
Cannot. You will hit your leg like that.
Then how? Walk one circle?
You have to walk out first, then push in your chair.
Oh my god. Just step out and push the chair and leave.
No, you must describe the whole process to be like in a very swag manner, very hype beast manner.
Hype beast. Okay.
Okay.
Different generation.
It is the word lah. It is the word that YPs are using. Okay, part 2. Find the probability of the event that both a randomly chosen durian has a selling price exceeding $10 and a randomly chosen bag of mangoes have a selling price exceeding $4.20. Okay, now I'm going to okay, so now we want a randomly chosen durian and a randomly chosen bag of mangoes. Okay, exceeding $10 and exceeding $4.20. So we need to find 2 probabilities and multiply them together. Okay, so firstly, the durian 1 kg is $7. Okay, so now we want to find $10. So how to find $10? It's actually what?
0.7. Huh? Not 7 over 10. Oops, my bad.
Correct or not?
No, it is. No, my bad. It's 10 over 7.
Correct, right? Okay.
Yeah. Sorry.
Yo.
So embarrassing. Stop recording.
You should be embarrassed.
Ask me the question again. Okay, cut this part out. Ask me the question again.
Okay, so what is how much will $10 worth of kg of durians weigh?
10.7.
Yes, perfect. You got it right at first try.
10 over 7.
Let's carry on. So, okay, moving on.
Okay.
So a randomly chosen bag of mangoes has selling price exceeding $4.20. This one we already have already, right? This was from part 1. Make sense?
Yeah.
So all we need to find is for durians. So we need to find the probability of a durian to be more than 10 over 7 kg. So can you find that for me using this distribution over here?
for 0.63951. Hello.
What's the answer?
0.63951.
Okay. So we want to find the probability of D greater than 10 over 7 multiplied by probability of W greater than 2.1. So this will be equals to 0.63951 multiplied by 0.18555, which is equals to
0.11866.
0.11 what?
866.
So it's equals to 0.119.
Okay. I asked me to check answer.
You should be confident.
Okay.
Okay, can I move on?
Yeah.
Part 3. My goal is to do 5 questions today.
Oh shit. Everyone, I hate math.
Yeah. You know, love and hate is like on a very different side of a spectrum. What? Sorry?
Huh?
What do you say?
Nothing. I didn't say anything.
Why can't I delete it? Shit. Something is wrong. Oh, can already.
Wait, you want to teach me a hate?
What?
Like after normal distribution, you want to start teaching me sampling distribution?
Huh? What? Again? I didn't. What do you say?
Like, after you do normal distribution, they can teach a hate for sampling distribution.
Can?
Really?
Why cannot?
Okay. I just want to be a head of lectures.
Oh, you want to be ahead?
Yeah.
Sure. Can. But I need to make sure normal distribution is steady first, right?
Quite solid. This is my first time doing it, and like we started.
Exactly. That's what I was trying to say. Because it's your first time doing, then you suddenly tell me you're damn solid.
I see it's a joke.
No, trust me.
I hate stats.
Huh?
My whole of stats is
No. You are like liquid right now. You're definitely not gas, but you are like liquid. You're going to become solid already.
Oh wait, there's one part that there's the expectation is plus minus. Like example, A plus B equals E
You know
A
you can
plus minus.
draw on the screen, right? You can annotate on the screen.
Yeah, but I got no pen, right? A bit ugly. So
Expectation of what?
No, A plus B.
Expectation of A plus B
Equals EA plus minus EB. Is that for binomial or everything?
Everything. The properties of expectation. Okay.
Wait, so that means just now that
To
question.
everybody listening to this, what should I call this? To everybody who is listening to this video right now, right? The properties of expectation and variance, right? Okay, are the same. It will apply to all distributions. Okay? It will not be different for anything. It's the same. Okay?
Wait, but then just now that question, it was just plus. It wasn't even plus minus. But if there's plus minus, then it's a different answer.
Why would that be plus minus? What do you mean by plus minus?
Okay, wait. Shall I just draw it out? As in,
Hey, you just draw. I will try to rewrite your. Yeah. Okay. What this is trying to say, right, is in your notes, right, you will see something like that.
yeah. Okay, yeah, that. My bad.
What they are trying to say, right, is that expectation of A plus B is equals to expectation of A minus expectation of B. Sorry, plus. Then on the other hand, it is expectation of A minus B is equals to expectation of A minus expectation of B. That's what it's trying to say.
But then variance is minus.
Variance,
Always.
no matter what, you'll be plus one. No matter what.
Huh?
Always
Minus.
plus. No, variance, just I mentioned already, you go back and review the video
Oh, is
again.
it because no matter how you square, it's always plus?
Yes, obviously, right?
Yeah, okay, that was my only confused part. Okay, but yeah, okay, I'm done.
Thank you. Carrying on.
It's for the viewers to know.
Yes. Find the probability that the total selling price of 2 durians and 3 bags of mangoes is less than $33.50. So we have 2 durians. No, now we want 2D plus 3 bags of, sorry. 2 durians
3W.
means D1 plus D2 plus M1 plus, sorry, not M1, W1 plus W2 plus W3. Okay.
Oh, I said 3W. Oops.
Yeah.
Cut that out.
Obviously, no.
Cut that out.
No.
Okay, I'll
So,
repeat it again. Everybody, if it's 3 bags of mango, so it's not
this is going to make it
3W.
even funnier.
No, stop.
Okay,
We have to cut it out.
so
I actually knew what I was saying.
so now probability that the total selling price of 2 durians and 3 bags of mangoes is less than $33.50. So over here, we are going to redefine this new random variable, which is, let's say, maybe use my name, math with Kenny. So use K. So K is equals to D1 plus D2 plus W1 plus W1 plus W2 plus W3. So over here, we want to find the probability of K to be lesser than $33.50. So how should we calculate that in terms of weight? Oh, this is a big question. How are we going to calculate that in terms of weight?
You have to plus together to find the kg, and then after that divide.
Really? But how?
Wait, a whole bag of mango is how heavy? Like what's the mass?
No, they did not say. They just say that 1 kg worth of mangoes is $2. That's all they said. My brain is no longer functioning.
This is your second question.
I understand, but I started at 10 a.m. in the morning.
Oh, why?
What? Why I have lessons?
Doesn't everyone have school?
I have like this one student, right? He was like, "Yeah, forget it lah. I'm not attending that lesson." He said he doesn't understand what his teacher is teaching.
Oh.
You think about it first. Let me go and get some water. I'm thirsty now. Yo, man.
Yes. Can we just make it into unknowns?
What's your plan?
I don't know, make it into unknowns or something. How to
Make it
tell?
make it into unknowns. 2 durians. We want it to be less than $35.50. Wow, this is damn tough. How are we going to find 2 durians and 3 bags of mangoes? We want it to be less than $33.50. What's the weight? $3.50 worth. 1 durian, 1 kg durian is $7. But it's like trial and error already. What are they testing us here?
Oh my god.
What are they testing us? The probability that the total selling price of 2 durians and 3 bags of mangoes is less than. Question mark. Okay. What's the intention of the setter? What's the intention of the setter? $33.50. If you want us to convert the price to weight.
I think that the mass of the bag of mangoes is 2. So the price would be $4.
The mass of what?
The bag of mangoes, like W1, W2, W3, they're all $4 because they're all 2 kg.
They're all 2 kg. Why?
Oh, I got it! I got it!
Really?
Because the mangoes are sold in bags of 5, right?
Okay.
So, oh wait, never mind. Was there a false alarm? Okay, maybe like 1 of it. Oh, because the mean is 0.4 kg, right? 0.4 times 5. 0.4 times 5 is 2 kg. So in 1 bag is 2 kg. That means, and since 1 kg is $2, that means 2 kg is $2. Then you can find the individual mass of the durians. Then you just divide by 2.
No, I have to find it collectively. I have to find $33.50. $33.50. I need to find how many kg is it. Do you have solutions for this?
Yeah, I have.
Okay, let's check. Cannot already.
They
Haven't upload.
never, no, they never write anything. They just calculated as total. Okay, wait, let me find. Wait, can I share screen?
Oh, you want to share screen? Can. But this whole thing will be gone.
Huh?
All my distributions here will be gone, but never mind. I'll take a photo first. Wait.
Okay, never mind, no need.
No, it's okay, it's okay.
I'll just read out the answer to you. It's only one line. The answer is only one line.
Why not you take a photo and send me?
This is so stupid.
The answer is only 1 line, but it's 5 marks. Send me already.
Yeah. Oh my god, I don't think you can see it. It's not clear. It's actually not clear. Okay.
Huh? 10.5?
See, I told you I'm correct.
No, what is 10.5?
It's the individual mass of the durian. Basically, because one bag has 5, right? And so the total mass of the bag will be 2. So you just take the what is it, 33.50 minus 4 times 3, then divide by 2 to find the individual mass of the durians. You get it?
Oh. No.
It's wrong.
You know what they did? I'm looking at solution. What they did, right? Our method is totally different. They converted all the, you see, over here, right? What I did was I converted I converted the price to kg, right?
Yeah.
I converted the price to kg because the distribution that they gave us was all in kg. That's why I don't want to deal with the conversion of the distribution. Correct?
Yeah.
Yeah, but your school, right? They converted all this distribution, right? They converted all this distribution to dollars instead. So 1.5 kg, right? If you look at your first part, right, or the second part, right, you'll see that they converted 1.5 kg in terms of dollars. Because 1.5 kg itself is $10.50. Because 1 kg is $7. So 1.5 kg will be $10.50. That's how they get 10.5.
Okay.
You understand what I'm trying to say?
Yeah.
Yeah. So for the first two parts, right, it was still possible. It was still possible for me to convert. It was still possible to still convert the dollars. Like over here for $4.20, we have $10 here, we have $4.20 here. It was still possible to convert the dollars to kg. But for the last part, right, it's impossible to convert dollars to kg already. Because we don't know how many kg of durian and how many kg of mangoes will make up $33.50. Are you with me?
Yeah.
Yeah. Therefore, we cannot convert dollars to kg already. We got to convert the distribution. We have to convert the distribution here from kg to dollars.
Okay.
You understand what I'm trying to say?
Yeah.
Yes. So, in other words, in other words, right? Uh, 1.5. Okay, just so we know that 1.5 kg is equals to $10.50, right? Remember? Because 1 kg is $7.
Yeah.
Agree? So over here, the durian, originally the distribution was 1.5, 0.2 square. Correct?
Yeah.
Yeah. But now all these are in kg. All these are in kg. Now I want to change all these to dollars instead. Okay? Can? So we know that so now I have to define like maybe D to be in terms of the is the dollar of is yeah, we have to change it to dollars lah. So it will become 10.5 over here. Then over here will be 0.2 square is 0.04, right? So you have to find 0.04 kg is how many uh, dollars? Can you find for me?
Okay. Zero point 00381. Okay. Wait. Huh? Is it 28?
I don't know. Is it?
Wait, what? Wait, what the heck? Why are my numbers like this?
Can you give me 2 minutes? You calculate first. If not, you can check with your solution first. Because I want to know how they find the variance. I don't understand how they find the variance. Yo, I'm back. I'm back.
Oh my god, it took you ages, bro. It was like a solid 15 minutes.
Yeah, I had to go down. I was waiting for the dudes. Okay. How you know how to calculate the variance already?
No?
It should be in the solution set.
There's nothing.
The solution never give anything. Okay, but,
No,
but
I sent
okay.
you.
Okay, but firstly, we know how to, you understand this part, right? The 10.5 one.
Yeah.
Okay. So for 0.02 square kg, it will be 0.02 times 0.02 is 0.0. 0.2 times 0.2 is 0.04. So 0. Get my own calculator.
I got 0.28, but it sounds so odd.
No, that's not it. That is not it. Uh, 0.04, 1.5 kg, so it's 0.04 divided by 1.5 times 10.5. It cannot be here. The answer that you gave me was not there.
How about we just skip this question? It's so much work.
Can we skip the last part? Because the conversion doesn't make sense. We are usually in A levels, right? We will not need to convert the mean and standard deviation. Like we should be using the units as it is. If anything, right, and any slight changes to the mean or standard deviation, right, it will be from kg to grams or grams to kg only. You understand what I'm trying to say?
Yeah.
Yeah, but now we are doing like a proportion conversion from the mean to from kg to dollars, which is freaking ridiculous.
Yeah.
Yeah. Okay. It's not that I don't know how to do this question. It's that it's way out of line.
Okay. Why do question 3?
Yeah, let's do question 3. Not very clear, but a factory produces a particular brand of oil. Okay, blah blah. So we know the distribution is all here. Okay, explain why the amount of oil can be modeled by a normal distribution. Why? Even though the amount of oil cannot possibly be negative. Explain why the amount of oil in a small bottle can be modeled by normal distribution, even though the amount of oil cannot possibly be negative.
Because it's independent.
even though the amount cannot possibly be negative. Wow, shit, I really not thinking now. It's like my brain is really not thinking. I think there is really a quota to a number of questions a person can do a day. Explain why the amount of oil in a small bottle can be modeled. What are they testing here? They are testing on the properties of normal distribution. The amount of oil cannot possibly be negative. Oh,
The curve, right?
yeah.
What's the maximum value of the curve is at x equals to the mean. Expectation. Mean. Therefore, the mode is at mean.
Sorry again. What's the answer?
So the maximum value of the curve is at x equals to the mean. So the mean is at the mode value. Therefore the mode is at the mean value.
Oh, that's the answer.
No, I'm just reading the properties of the normal curve. So it's a good answer.
I want to give up already. I don't know what they're asking. 3 part 1. I will flip the paper over and walk out.
No.
Explain why the amount of oil in a small bottle can be modeled by a normal distribution. Explain why the amount of oil in a small bottle can be modeled by a normal distribution. Because it has a variance and a mean. Because the mean is...
They said that the probability of S less than 0, then the wavy line 0, hence a normal distribution can be used to model it.
That's the answer.
Yeah.
Again? Can you say it again?
Probability of S less than 0, then the wavy line, is it approximately 0? That's why it can be a normal distribution.
Oh yeah, because it is negligible. Because the probability of S less than 0 is... Because the probability of S less than 0 is negligible. Yeah. Because they are saying that this probability here is very small. That's why it can still be a normal distribution. Yeah. Okay. Let's move on to part 2. 3 small bottles are chosen randomly. Find the probability that one of the small bottles contains more than this and 2 other small bottles contains less than that. Okay. So we want to find the probability of S we're going to find the probability of S lesser than 602. Can you find that for me?
Uh, 0.054799.
0.054799.
054799.
Okay, so this is the probability of the amount of the whatever thing, the oil, less than 602, right?
Oh.
Correct.
Yeah.
So now I want to use binomial distribution. So I'll let, for instance, x,
Binomial.
yeah, be equals to the number of bottles. Oh shit! I cannot use binomial distribution yet. No. Ah, sorry. So I have 3 chosen bottles. So then the next move will be to find S more than 615. Can you find that for me?
Uh, 0.15866.
15866. Okay. So we want 2 small bottles less than 602. So it's probability of S less than 602 square times probability of S greater than 615. Check if the answer is correct.
It's such a big number. Plus or times?
Times what? I put bracket.
It's 4.76444937 e to the power -4.
It's not a big number. What? It's -4. E means times
Yeah,
10
but
to the
then
power
there's an e
-4.
what?
Yeah, E means times 10 to the power -4.
The answer is 0.00143.
Okay, so it's 0.00143. Is that the correct answer?
Yeah.
Okay.
Huh?
Huh?
Oh, as in that's the answer, but what I got was 4.76444 times
4.76.
445 e to the power -4.
Okay, means times
That's
10 to the power of -4.
so far off, yeah.
Oh, okay. Means you need to multiply by 3 choose 2 factorial. 1. Means you need to multiply by 3 choose 2.
How why?
Or alternatively, what you can do is, or multiply by 3 factorial, 2 factorial also can. Because you have 2 identical, you have 2 lesser than 602, and you have 1 that is greater than 615. So you need to rearrange how you can choose them. So this will be 3 factorial over 2 factorial. You understand?
Yes.
Yeah. So if you use this times 3, you should get an answer. Let's try. Yeah. Correct.
Okay. So I can take 3 factorial over 2 factorial
Because, like I said,
but how do you know we have to do that?
because you have you won't know. You won't know when it's the first time doing normal distribution. But as in the first time doing this kind of question, you will know. But a few times later, you will know already. Because you see, you have two of the same. How do you know is this probability times this probability times this probability? How do you know it's not like there are different arrangements to this? You don't know which is the bottle. You don't know which is the bottle, right?
Yeah.
Yeah. Or that's why I say 3 choose 2. Or rather 3 choose 2. I think 3 choose 2 will be better than 3 factorial or 2 factorial. Because 3 choose 2 is to the what are you choosing here? What is the 2? The 2 is you're choosing which 2 are the small bottles containing less than 602.
Yeah.
Yeah. So these are the 2 containers containing less than 602, right?
Yeah.
Yeah. So you're choosing the 2 bottles. Then again, some students will ask me, hey, Kenny, can I don't choose the bottles less than 602 or not? Sorry, it's a typo. God, I hate math. Seriously hate math.
You can't say that to our viewers.
I don't care really. I want to quit my job.
You cannot ruin your image.
I don't care. I'm damn done with this. Okay. Probability of S lesser than 602 and this probability of S lesser than 602. So some students will ask, hey, why should I choose the bottles that are lesser than 602? Why can't I choose the bottle that is greater than 615? Right? Can. You can do that. Because if you want to choose that one bottle that is greater than 615, it'll be 3 choose 1, right?
Yeah.
Yeah. But is there a difference? Why is 3 choose 2?
Like the value.
Yeah.
Oh, you're saying, okay. 3.
3. Why 3 choose 1?
3.
Exactly. So there's no difference to it. Understand now?
Yeah.
Yeah. Can? And we can move on to part 3, right?
Yeah.
Find the value of sigma such that 80% of regular bottles contain between 1040 and 1060. Okay, this one should not be difficult. We want the probability of the regular bottles between 1060 and 1040. Okay, and this equals to 0.8%. So we know that our R follows normal distribution 1050 and sigma square. So what should we do? Okay, so firstly, we have to draw the graph. This is 1050, right? Because the mean is 1050.
Yeah.
Okay. Obviously, right over here, we do not have the sigma. Correct?
Yeah.
Yeah. Which means whenever you don't have the sigma, right? You don't have the parameters, either sigma or mu, right? You always need to do this thing called standardization.
Yeah.
Okay. So you know about this technique, right? Hello?
Yes.
Yes. Okay. So we take a look here first. Before we even proceed with standardization, we take a look here first. They say between 1040 and 1060, the probability is 80%. The probability is 80%, this whole chunk here. Okay. And we also know that the distribution, the normal distribution, right, is symmetrical about the mean 1050. Do you agree?
Yeah.
The probability is symmetrical about the line 1050. So if this whole thing here is 80%, what do you know about
80%.
sorry, what do you know about this area here and this area here?
20%.
The addition is 20%, right? Which also means that the probability of R less than 1040 is equals to 0.1.
Yeah.
Make sense? Okay.
Okay.
Then from here, I want to do standardization. How do I do standardization? So it will be let Z be equals to R minus 1050, which is mu, over sigma. Follows normal distribution 0, 1. Then we can have probability of minus 1050 over sigma is lesser than 1040 minus 1050 over sigma is equals to 0.1. So from here, we have probability of Z to be lesser than minus 10 over sigma, which is equals to 0.1.
Okay.
Okay. So from here, we have to find what is this thing, right? Which we have to use what? Inverse norm. Okay.
Huh, serious?
Yes. So by inverse norm, a lot of things to use. A lot of things. And it's only 3 marks. You must be thinking that, what the crap, right? That's math for you. But it's okay. It's okay. You only need to hate it for the next 6 months, right? Then you're done really. But for me, right, I have to hate it my whole life. It's very sad.
Okay.
So right, let's carry on. So by inverse norm, you have to use the GC, you have to choose the inverse norm function. So can you choose the inverse norm functions for me? Thank you. So the area, right, you have to key in 0.1, and the mu will be 0, and sigma will be 1.
Say again.
The mu will be 0 and the sigma will be 1.
But then the area is at what?
Area is 0.1
Oh,
over here. Okay. So after which tail to choose, you have to look out for this inequality here. Is it lesser or greater? If it's, you see, it's pointing towards the left side, right? Look at, if you see this as an arrow.
yeah.
Yeah. So the tail will be left tail.
Wait, so the mu is 0.1, then the
No. Mu is 0, sigma is 1.
the area is 0.1.
Yes.
Okay. Negative 1.28155.
Okay, so you will get that your minus 10 over sigma is equals to negative 1.2815. Yes. So from here, you will be able to find what is your sigma. Understand?
Seven point eight one, 7.8031.
Yeah, that should be the correct answer.
Let me check. Yes.
Yeah. Okay, but
not bad.
first and foremost, right, I need to explain to you why I did this.
Okay.
What is the main reason why I intended to do this? Because I have already seen this kind of question before. Okay, if you have to do with inequalities on both sides, okay, after you standardize, right, okay, you will be in very, very deep trouble. Okay, you will meet a lot of complications. even if you were to if you were to standardize with inequalities on both sides. Okay, I just need you to have a mental note or write down somewhere. Okay, write down in your notes. You have to write this down. Whenever you want to standardize, okay, reason for standardizing is because parameters are known. Okay, reason for standardizing is because the parameters are unknown. Okay, but what to take note of when standardizing is that you got to make sure there's only one inequality. One inequality. You have to make sure that there's only one inequality present. You have two inequality on the left and right hand side, right? Don't do that. Some teachers will tell you that no, never mind, it's okay. Don't do that. Just make sure that there's only one inequality. That's why I decided to find, that's why I decided from here, right? I decided to draw the graph so I can understand how can I change the double inequality to one inequality. So identify that, oh, I can either write probability of R to be lesser than 1040 or probability of R to be greater than 1060. They will still give me the same probability.
Okay.
Can Okay, lastly, find the probability that the total amount of oil contained in two randomly chosen large bottles exceeds 4 times. Okay, look here. We have two randomly chosen large bottles. Is it 2L or is it L1 plus L2?
L1 plus L2.
Correct, because it's two randomly chosen. You went to the supermarket, you choose two random large bottles, means you chose two different ones, right? Okay, then the next one is 4 times the amount of oil contained in a randomly chosen bottle. How are you going to express this? 4 times, sorry?
4 times, like 4 times L.
No,
L.
wrong.
4 times the amount though.
Yeah, but it's not 4 times L.
As in 4 times of, okay, 4S.
4S, correct.
I didn't know the L was large. Okay, my bad.
Okay. So over here, we have to find the probability that the L1 plus L2, okay, exceeds 4 times of S. So over here, we need to define a new distribution, which is L1 plus L2 minus 4S.
Okay.
Okay, so from here, you should know that, okay, find expectation of L1 plus L2 minus 4S. Then find the variance also. You should be able to do this. Can you show me? Or rather, you can let W be L1 plus L2. Let W be equals to L1 plus L2 minus 4S.
Expectation is 610 plus 1050 plus 1200. Is it?
When you get the final answer, you will know.
Okay, let me think. My variance is 0.
Okay, then go ahead and calculate.
It's wrong. As in, they don't let me.
Then cannot be 0.
My expectation is negative 40.
I don't have the solution booklet, so I cannot check for you. But what's the variance of L1 plus L2 minus 4S? You say variance is wrong, right? So how do you find variance of L1 plus L2 minus 4S? Can you tell me how you find?
I just took 50 plus 50 minus 4
Wrong.
times 25.
Why you use minus? You cannot use minus. Remember, for variance, there will be no minus.
Oh shit. Half
Yeah.
plus.
But I'm glad that you made the mistake now.
Also, you knew
Yeah, confirm. I guarantee almost 10 out of 10 of my students, almost 10 out of 10 of my students, right, make these mistakes on first try. I was waiting for, that's why I asked you to do this one. I was waiting for you to make the mistake. Nobody ever got it past first try before.
The answer is 0.4207, but the answer is wrong.
I mean, somehow you calculated wrongly. Okay, come.
My expectation wrong.
How do you calculate expectation?
1200 plus 1200 minus 4 times of 610.
Correct.
It's negative 40 though.
Okay, so let's say it's negative 40. So you will know your variance. Do you key in sigma or sigma square? You have to ask yourself. Over here is variance of L1 plus variance of L2. So it's 2 variance of L plus 16 variance S. You key in 4 variance S, right? Or what?
Yes.
You key in 4 variance S?
Yes.
Nice, correct. Remember this mistake. You don't want to make it during A levels.
Okay. Still wrong.
Okay, it's time for me to do it. I can do this. Let's say it together. I hate math. Expectation of L1 plus L2 minus 4S. Okay, so it will give me expectation of expectation of L minus 4 expectation of S, which is equals to 2 times expectation of L is 2,400 minus 4 times expectation of S is 2440. 2440, yeah. So you should get minus 40. Then for variance, it will be 2 variance of L plus 16 variance of S, which will give you 2 variance of L will be 100. 16 variance of S, 16 times 25 is 400. So you should get 500. So when you key in, right, you should key in square root 500. Okay?
Square root 500.
Yeah, because this is variance one.
What the heck?
Good. This is also another thing. You committed every single mistake that you committed.
Are you freaking kidding me?
You committed every single mistake that any A-level students could have committed, which is damn good. It's a triple combo.
Wait. What's all the mistakes?
Okay, remember number one. Really, this is everything. You really committed everything. Firstly, right, number one is that for negative signs in variances, right, there are no negative signs. Okay. Number two, when you factorize, also about variance. When you factorize, right, when factorizing, the constant should be squared.
Yeah.
Okay. Number three, when also about variance. You see, this variance will kill people. When keying into GC, okay, when keying into GC, make sure to key in sigma and not sigma square. And not sigma square. It's a no-no. Okay, all 3 pointers are on variances. Can? You try keying it again, slowly, and you should get it.
Correct.
Yes, Nat, you did it.
Dude, this took way too much of our time. What the heck? Stupid question.
You did it. No, it's fine. After a while, you'll do it pretty fast. But just now, the second question was a bit too much of a drag, really, because of the conversion. Yeah, I honestly don't like this kind of question. It's not really I don't like. It's like the intention. It doesn't test the normal distribution concept. Yeah, it's not an A-level question, basically. It's not an A-level question. A-level question will never test it like that. Okay, but this is an A-level question. I must highlight to you. Although we had difficulty solving this, this is an A-level question.
Okay.
Can?
Yeah.
Okay, if not, right, let's call it a day and let's have a good rest and dinner.
Okay.
Yes. So we have come to the end of Math with Kenny. So if you hate math, please like, share, and subscribe. Thank you for your attention.
Bye.
Bye-bye.